Well, screen's off.
I think it's a sign.
It's a sign.
There we go. We're good. Okay, cardioids. So yes, heart. And I mean, I guess those aren't great looking hearts, but they're about as much of a heart as those roses were roses yesterday, right? Like it's close enough to call it a heart, I guess. But that's where the name cardioid comes from. Limaçon, I don't know where that name comes from. And if you want to be really fancy, that C is, it's a French word. It's the C that has the little, I don't know the name of the thing. If anybody's in French, we don't even offer French anymore.
We don't?
Or do we?
No, I think we do.
We do? Is anybody in French?
We were.
What's the name of the C that has the little hooky thing on the? I don't know. But it's pronounced sort of like an S. So it's a limaçon, right? It's not limacon, right? It wasn't a Texan that discovered these. It was a Frenchman. So limaçons. The reason we do them together is because their equation, like the graphs don't, well, I guess maybe they kind of look similar, but the equations is the same, a plus b sine theta or a plus b cosine theta. And the relative value of a and b determine if it's a cardioid or a limaçon. So that's why they're grouped, is because their equation looks the same. They're separate because their graphs look different, and their graphs look different based on the values of a and b. So for a cardioid, this is the special case. If a equals b, and I guess I should put absolute values on those, because we're not worried about the signs really. But if the values are the same, then you get a cardioid. Cardioids are heart-shaped. You can put that in quotes if you like. Is that a heart or not? They do always go through the origin. Make them nice and plump. We'll talk about like the 4 key points, but it's like when you're graphing, you know the shape of things. Don't just play connect the dots with the points. Make them very, very circular, rounded. Before we get to this one, the cosine is an x-axis cardioid, and the sine is a y-axis cardioid. So that x goes with sine, x goes with cosine, y goes with sine. That continues today. And if it's a positive cosine, then it's on the positive x-axis. If it's a negative sine, it's on the negative y-axis. Plus or minus depending on b. That would be for both of them. Plus or minus, the b will tell you if it's up or down, left or right. Okay. So for this example, 2 plus 2 sine theta. So we know it's a cardioid because a and b are equal. I mean, we're obviously in the cardioid section, but if you stumbled upon this equation out in the wild, a and b being equal mean it's a cardioid. Sine means it's on the y-axis, and the fact that it's a positive sine means it's on the positive y-axis. 2 plus 2 is how far you go on the positive y-axis. You can even say that 2 minus 2 is how far you go on the other side of the y-axis, but 2 minus 2 would be 0. So this b is like the main axis of the problem. For this one, it's the y-axis. You got to be careful because when you switch sine to cosine, it switches what a and b do. A is sort of the other axis, so we'll go out a on either side, and those will be our 4 key points. And so, again, you don't play connect the dots with those. You have to fit a cardioid to those points. If the 2 was negative, that's the A, so that would switch these two, but that really wouldn't matter in terms of the graph. Like it would, if we were thinking about what order it was graphed, it would matter then. We're not going to worry about that. But at the end of the day, those would be the same pictures. So let's do 3 plus 3 sine theta. So the first thing I see is that it's a positive sign. So I know this will be on the positive y-axis. So 3 plus 3, that'll get me up the positive y-axis. So 1, 2, 3, 4, 5, 6. Three minus 3 is the other end of the y-axis. Obviously, that's always going to be a 0 because A and B are equal to each other because it's a cardioid. The A is the sides. Be careful, it's not always left and right. It's because this is a sine, it's left and right. For cosine, it would be up and down. So we'll go 3 out on the sides. Again, this is one of those places where those are your 4 key points, but you don't just play connect the dots and make a triangle. You need to make it a rounded, circular, plump looking cardioid. So again, if you just try to think, make it circular, that'll be your best bet. Again, it does not look like, right, that's not what we want. That's more of a heart when we think of drawing a heart for Valentine's Day, but that's not a cardioid. Okay, 2 minus 2 cosine theta. So negative cosine means we'll be on the negative x-axis. So I need to go left. 2 plus 2 is 4. Two minus 2 is 0. But thinking 2 plus 2 and 2 minus 2 will help when we get to Limacons. So 2 plus 2 is 4. 2 minus 2 is, of course, 0. And the sides are 2. The sides on this one are up and down because it's a left and right cardioid, so the sides are up and down. And again, it's always going to look like a triangle looking thing if all you have is the 4 main points, but you know that it's a very circular, plump cardioid, so as best you can, make it nice and circular. I'm not going to take off if it's not perfect, but if it looks like that, I probably will take off. Like that's not circular enough. Why don't you try that last one? Negative sign means negative y-axis. 4 plus 4 is 8. 1, 2, 3, 4, 5, 6, 7, 8. 4 minus 4 is 0. And then the sides are also 4. And again, the pictures look good. You're not drawing like Valentine's Day hearts. You're drawing PreCal cardioids.
Wait, so does that negative in front of the first 4 just mean nothing?
It really does. Well, I shouldn't say it means nothing. It means that instead of my first point being here, my first point is over here. But the final look of the graph is the same. Because it switches it, but what does that matter? It switches it left and right, but that doesn't matter. This negative switched it up and down. That did matter, like compared to the first one. But switching it left and right didn't do anything. So yes, this is the same graph as 4 minus 4 sine theta. Okay, so this is the backwards problem. Cosine or sine for this one? Cosine, because it's left and right, and positive cosine at that. because it gets back to the origin, that's how I know it's a cardioid as opposed to a limaçon, which means my two values need to equal each other. So if it lands out here at 6, what two numbers are the same and add to 6? 3 and 3. And again, this is one where you could put a negative sign out front, and that would flip it up and down, but flipping it up and down wouldn't matter. So -3 plus 3 cosine would be the same graph, just drawn a different order. Okay, so a plus b and a minus b for the main axis, and then just a on the side axes. Put that down somewhere. A plus b, a minus b for the main axis, and then just a for the side axis. That will hold true when we get to limaçons. So try to teach it in a way that works for everything. That way there's less to like memorize or learn. Okay, a little side note here. The number in front of theta must be 1 to be a cardioid. If the theta coefficient is not 1, then you get some crazy graph. You don't need to know these graphs. It's like this is sort of a combination of, I mean, it's like part cardioid, part rose. We're not doing anything crazy, but you can get some fun and crazy graphs with those things. We're not doing those. Like, we're keeping them simple. This would be like, you know what the graph of x squared looks like. You know what the graph of absolute value looks like. If you added them, it'd be kind of weird looking, but we're not going to do that. We're not going to add cardioids and roses together. Okay, limaçons. So this would be if A does not equal B. So if the numbers are different, then it doesn't make it back to the pole. It either has a loop or doesn't have a loop. Here's how I remember whether it has a loop or not. If it was just R equals A, what shape would that be? If it was just R equals A, that would be a circle. So I'm going to say A is sort of the part of the equation that makes it circle-y. And B cosine and B sine, that's the kind of thing that makes roses and loops. That's the loopy kind. So if the circle part is bigger than the loop part, then it's more like a circle. If the loop part is bigger than the circle part, it's more like a loop. So you can memorize the A's and B's like it's sort of written here, but I just think if the circle piece is bigger than the loop piece, it's going to be more like a circle. So this first one, limaçons without loop. A is bigger than B. That means it's more circle than loop. So my picture is going to be more circle than loop. I mean, it's not a perfect circle because it's got this kind of loopy part built in there, but it doesn't make a loop. Later on, if the loop part is bigger, it makes a loop. So I don't really remember the A versus B stuff. I remember R equals A as a circle, so that's the thing that makes it circle-y. B cosine theta makes it loopy, and so I just go with which one's bigger. That controls whether there's a loop or not. Ms. Murray is trying to say a different way here. If A is big, the graph goes outside the origin, that's fine. I just think circles and loops, which one's bigger. Okay, we're going to, if we can graph these, sort of the same thought process as the cardioid is my hope. So positive sign means it's on the positive y-axis. 3 plus 2 is how far out we'll go on the y-axis. So A plus B is that number. The sides is still A, right? It's like that's how far we went out on the sides. So A plus B is the longest away. Just A is the sides. And then A minus B, although we have to be careful with the absolute values, A minus B is the the other side of things, which was the same for cardioid, but for cardioid it happened to be 0. So again, trying to teach these and learn these where it's sort of the same thing, and then if A equals B, well then you happen to get back to the origin, and that has a special name, but it's still the same process as Limason graphing. Okay, so let's try one of these. 4 minus 2 sine theta. So first question is, what's like the main orientation of this Limason? Negative y. Negative y axis. Oh, and I guess we should have said this first, even though we're in the whole section without loops. This is circle is bigger than loops, so this is a circle-y Limason. The more official way would be no loop Limason. So circle-y, it's on the negative y-axis, and then I can start using the same process. A plus b, ignore the signs, because the signs told us to go down, so I've already accounted for the sign. Better way to say it. A plus b is 6, so I'll go 6 out. So there's my a plus b. My sides are 4. 1, 2, 3, 4. 1, 2, 3, 4. Again, a plus b for the max. A is on the sides, and then a minus b is the other side. So a plus b for the long side, a minus b for the short side, and a is on the sides. And again, draw it circular. It's not a kite, right? You don't play connect the dots. Try to draw it as rounded as possible. And most of these have very slight dimples, so it's rare you're going to have one that's like, like it's not going to look like that. All right, 3 plus cosine. Okay, so which way are we going? What's our orientation of this thing? Positive x-axis. Loop or no loop? Is it circle-y or loopy? It's circle-y because the circle part's bigger. So 3 plus 1 on the positive x-axis. Three on the sides, because that's the A is the side. So 1, 2, 3. And then how far back the other way? Yeah, 2. 3 minus 1. A minus B. And again, put a circular Limason on there, not a connect the dot situation. Okay, the third one. What's the main orientation of that Limason? Good. Positive y-axis, not the negative y-axis. That negative 5, positive y-axis. So we'll go up 7, A plus B. And then sides are 5. Again, the negative means they're like switched, but that doesn't really matter, because if you switch the graph that way, it's going to be the same graph. 1, 2, 3, 4, 5. And then A minus B is 3. So there's my 4 key points. Again, please do not play connect the dots. Maybe we should have looked at the example pictures first to see how rounded they are and how little the dimple is on most of those. All right, you try the last one. So I'll go out 9. 5 on the sides. 1, 2, 3, 4, 5. The negative doesn't bother me. I mean, if I'm really thinking about it, it switches, but that doesn't matter. And then 5 minus 4 is 1. Okay, so like the more extreme it is, the more dimply it'll be. So this one is going to have a little bit more of a dimple look to it than the others. Well, that wasn't very symmetric, but you get the idea. All right, then we have some where we practice writing the equations. Again, you think through the same type thought process. So this is on the positive x-axis, so I know it's plus something cosine because it's on the positive x-axis. And then, let's see, I know it's got to get out to, goodness, that's 5. But it's probably easier to look at the sides because we know the sides are a. So if I do the sides first, that's 3. And then if I need to get out to 5, then that needs to be 2. And sure enough, 3 minus 2 is 1, so that checks out. That would be most people's answer. What would be the creative answer to that one? Negative 3, because that would flip it up and down, which wouldn't change the graph at all. Okay, the next one is pointed down, so that's negative y-axis, that's negative sign. So put that on first. And then I need a plus b to equal 8, but I'm not really worried about that. I'd rather do the sides first. 1, 2, 3, 4, 5. So my sides are 5, so that's what goes in the side spot, the A spot. And then to get to 8, that's got to be 3. And then to check, 5 minus 3 is 2. So yeah, I feel good about that one. And again, you could put a negative on the 5, and that would switch it left and right, which wouldn't change the graph at all. Okay, that one looks like a circle, but it's not a circle, so let's see, it's pointed out to the left, so that's going to be negative cosine. And it goes out to 5. But the sides are what matter more. So the sides are 4. So 4 plus 1 would get me to 5. 4 minus 1 would be 3. So yeah, that one checks out. And again, you can put the negative on the 4, and that wouldn't change anything. And then lastly, let's see, that's a positive sign. The sides first is 4 and goes out to 7, so 4 plus 3 is 7, 4 minus 3 is 1. Again, you got like multiple built-in checks on these things. Another picture that you're not going to have to draw is, again, this sort of combination of Limason without a loop, but also a rose, and you get these weird pictures. You are not going to have to graph those.
Is that an AP? Or
What's that?
is that an AP? Or
An AP, is that what you said?
yeah, you
No. No, it's just when you start combining these things, you get weird pictures. And kind of fun pictures, but not pictures that you'll have to be able to do. Okay, Limasons with loops. So these are the ones that are a little bit tricky, maybe. If the loopy part is bigger than the circle part, then it's got a loop. So if the loop, which is the B number, is bigger than the circle part, which is the A number, then we've got a loop. Same process though, A plus B. Am I good, Addie? Okay. Same process as the cardioid, same process as the Limason without a loop. Think through what's the main axis, A plus B, just the A's. So it's the same stuff, but we're going to have a loop in there. Let's jump to this first example. Okay, so positive sign means I'm on the positive y-axis. A plus B is 4. 1, 2, 3, 4. My sides are at 1. So sides are at 1. A and A. And then my loop is still A minus B. I can still think of it that way. 1 minus 3 is negative 2. So instead of going out 2, I'm going to go up 2. And that's A minus B. Now these are sort of extra tricky to graph, because that's like, how do I fit a cardioid with a loop through there? I would say they do always go through the pole. They always go through the origin. So you can add that as a point. I don't know. Okay, let's see if we can draw this. I like starting at the origin and then doing the big loop first, and then doing the inner loop. Start at the origin, draw the big loop, draw the little loop. That's, if you start at the origin, that means you'll definitely go through the origin. Again, this is the one where you have to know what the shape looks like. You can't just try to figure out how to connect the dots. All right, the second one, what's the main orientation for this guy? Negative X. So I'll go out 3. That's A plus B. My sides will be 1. That's the A's. And then A minus B is negative 1, so that's what makes there be a loop. A minus B, and then again, I know there's a spot somewhere at the origin. Then that's where I like to draw the graph first. I'm going to start my graph at the origin. I'm going to make the big loop, and then I'm going to make the little loop. So big loop, and then little loop. To me, I think that's the easiest way to do that. Okay, so negative y axis. 2 plus 5 is 7. There's A plus B. My sides are 2. I guess you could say they're negative 2, and so that would switch the order, but that's not going to change the graph. A minus B is negative 3. That's why there's a loop. 1, 2, 3. So there's my 4 key points. Again, include the origin, start at the origin, draw the big loop, and then draw the little loop. Draw the big loop, and then draw the little loop. Why don't you try that last one? And then we got some where we think backwards. Again, follow the same thought process. So this is pointed left, so I know it's a negative cosine. My sides, the A sides are 2, so A equals 2. I've got to get all the way out to, what is that, 4, 5, 6, 7. So that's got to be a 5 to get out to 7. And that means my loop better be at 3 for this to work, and it is. So, and then what could I change and still have the same graph? The negative 2. That would flip it, but that wouldn't change the graph. Let's see. Next one is a positive sign. So plus sign. Do my sides first because that's the easy ones. That's the 2's. And then I'm all the way out at 6. So 2 plus 4 would be 6. 2 minus 4 would be negative 2. That's why I've got a loop at negative 2. And again, it could have been negative 2. Okay, I think that's enough of this. I think you got the hang of it. It's always figure out orientation first, and then A plus B. That's sort of your max. Use the A for the sides, and use A minus B. And maybe that shows you a loop, maybe it doesn't have a loop, maybe it goes back to the origin if it's a cardioid, and then sketch the picture. So that's sort of the order to think through all of them. And so you don't have to know ahead of time, is it a cardioid, is it a loop, is it a no loop? I don't know. Set the orientation, go to the max, go to the sides, and then you figure out the loop or no loop stuff with A minus B. Here's some more silly pictures that are fun to play with. You're not going to have to draw these, but when you sort of combine circles and roses and limacons, then you get like roses with loops. It's kind of cool looking. You're not going to have to graph these, but these are the things that's sort of fun to play with on your calculator. Put it in polar mode, you start putting crazy things in there, and you get some fun looking graphs. All right, today's assignment is the next worksheet, which is worksheet number 3, cardioids and limacons. Make sure you give your significant other a dozen red roses tomorrow.